Okay, so our next speaker will be Amarnath Gupta, who's going to be talking about connecting people to resources, and communication and dealing with lots and lots of data is going to be a central theme that goes through everything that we hear from all these days.
Thank you. I'm from SDSC and I'm a computer scientist, so I'll have a computer science bias in my presentation. But the area of computer science that is emerging and is relevant to my talk today is called social computing. There are multiple definitions of social computing. The old definition, 1994-ish definition, it said any branch of any aspect of computing or software that impacts social relationships and anything that might potentially change how people behave in a society. A more recent version of that is, can we have software that will take intelligence information from the society, from a group of people, and then do something with it? It could be as simple as crowdsourcing. Crowdsourcing is not simple, but so that's something that updates information. Or it could be more global, like something I would talk about today. So I wanted to go back to the theme and said, okay, what enriches a human's life? Well, a bunch of things, right? We'll talk about one. And the question we want to ask is the following. What exactly is a helpful and supportive social environment? Let's see. So if I have a social environment that's supportive, the following kind of thing would happen. People will watch on other people. I have my neighbor. If my neighbor is in trouble, I would sort of know about that. And not that I want to pry or I want to intervene, but if I sense it, I'm going to offer help. And if I offer help and the person accepts it, I would try to see that it's actually delivered, right? Now, that's nothing really abnormal. Happens all the time. And usually, that's done by a regular real-life social network, neighbors, family. The question we are asking is, can we technologically augment this process if we increase the number of people, the number of potential solutions, the number of resources, the number of situations? That's the question. So let's take this example. So there is a farmer in India who uses, by the way, everybody has cell phones these days, right? So they use their app to say, my crops are dying. And every day or every other day, they have new reports of what's happening to the crops, images, postings. Now, let's pretend that there is something which takes this and says, we really have an evolving situation here. Something is going wrong with this guy's agriculture profession. So that data is somehow assimilated into a situation, and it's fed into some global situation representation. This same global situation representation has other information. Weather data, drought databases, what has been happening, models. And it computes and says, well, for this kind of problem in this region of the world, maybe the crops have this kind of issues, and maybe it can locate through its own social network a bunch of people, experts, entomologists, whoever, who can look at the problem, try to understand the problem, and then directly or indirectly contact the farmer. Now, is this possible? Now, I'm going to take the same picture. I'm going to change the example. A person who is prone to depression but normally operates regularly, the person has a bunch of sensors that monitor the behavior, the different aspects of life. The person also has a digital presence. They say things on Facebook. They use their iPhone. A bunch of things are monitored on iPhones. There are companies today that actually manage and monitor the processes. How many emails do you make per day? What kind of sites do you visit? That sort of thing, right? And then these parameters are measured. The same thing. Somebody says there is a situation going on here, and it's an evolving situation. And pretty much the same thing happens except one. Now, I might not want to go through a social network-based mediation or social network-based intervention. I might have a direct intervention. So I might take an intervening measure by giving the person advice by asking him to do certain things, or maybe I will not do it directly. Maybe I'll send this information to the right family members or friends who would do it for the system. Now, what I wanted, this was very hypothetical and slightly provocative, but I wanted to show you that these two systems, hypothetically, should behave similarly in a certain sense. The technological infrastructure for doing this should have many common parts. Okay. Now, so what are we trying to do? We are trying to connect people to resources. The resource can be a person, a social network, an expertise, even a mediation, an intervention. Right? What are the pieces in this that are common? Well, we have to have information from multiple sources that we somehow need to integrate and compose. We need to figure out that there is a situation going on by assimilating this information. And we need to produce derived information from which we'll make alerts and queries and then make the connection. Let's go. So the question is, can we develop a social computational approach? And the three words that are very important are, they should be just in time, just the right size, and it should be really an intervention that works. So this is sort of an umbrella problem. There is no one discipline that can ever solve this problem. We, as computer scientists, can solve parts of it, maybe the algorithmic parts. SDSC, as an infrastructure place, can possibly have the right kind of machinery to have the computing done, but it will involve everybody else. Okay. So what are the pieces of this? One piece is clearly devices and networks, which could be personal or which could be global. If we are going to collect this data and ingest it, what should the databases look like? Because we are trying to integrate real-time data. Now, we are trying to, in the process, form a model of this person. Because if I say this is the situation with this person, the same set of circumstances may not be a situation for another person. So we need to do something, a data mining of sorts, to create a model. Yeah, I know I'm done with time. Okay. The second part I'm going to emphasize is that the situation is evolving, it's not static. The third part is all the resources eventually have to lead to a decision. We have to have a decision theory process before we can act. Now, the two primary collaborators is Ramesh Jain's group at UCI and STSI, the Scripps Translational Science Unit, that are trying to do this, and Scripps is trying to do this kind of thing on depression. And this is a very new thing. We have not really done something significant yet, but this is a very important problem. And we, as DSC, myself and my colleagues, have several pieces of this solution. At least we have approached, and we have some working knowledge, working software that works in parts of this solution. But the point here is that there are other projects. For example, there are current projects on campus that are complementary to this. And there is a ton of expertise on campus that can contribute to this problem. So therefore, and also UCSD is the right connection to all the device companies, businesses, networking companies that might contribute to this solution. So instead of just saying what I do, I wanted to present this problem which is really beyond any individual group. It's collaborative by definition. Thank you.
So I think you brought up one other question is collaborations between different campuses. So I think playing a central role with our computing strengths here, really being a bridge to not only across our campus and across the Mesa, but to other campuses as well.
Potentially. Yes, Suresh.
Even to tackle research problems, despite things like these workshops and so on, even to tackle a research problem, if there's this way of bringing together all the resources, whether it's the campus or the whole world,
right,
that could be, the same concept applies there. and you
Sure.
get the appropriate input from the various people. Have you tried something like that?
Not in that sense, no. I can only think engineering.
Andy?
Then
Can you describe for us one or two things that might be important resources or opportunities that could help you move forward in this?
Oh, there are so many.
Many. But could you describe, just give examples of a few things?
Okay, two things. So the obvious thing is we need people in the domain. Actually, talking about your work, we need the definition of what events should lead to what kind of intervention. And we need to figure out how we can translate that to something that a machine would be able to recognize and deliver. Second, I think economics has very interesting utility theory-based models. If you have so much information, the more you increase the amount of data, the greater is the question of data as a commodity and its utility in a certain situation. We have never seen that in databases, economic utility theory to be utilized in a way that we are talking about. I think that will be very valuable.